Hey everyone, my name is Nick Robertson, founder of Rare Combinations LLC, and today I'm going to be telling you how to use your alcohol percentage detector in the most accurate way possible by creating your own calibration curve. So the things that you'll need in order to prepare your own calibration curve is, of course, the alcohol percentage detector. You'll need a variety of different alcohol percentage standards, and I go through how to perform dilutions like this in another video that you can watch. And of course, the end goal is to find the alcohol percentage of your unknown sample or multitude of samples. You'll also need a computer and an Excel document that allows you to create the calibration curve, which I can provide upon request. So as we go through with the different samples, we'll be using the raw reading on the screen of the detector and insert those numbers into the Excel document in order to get a calibration curve for the detector. Now, once we have the calibration curve, we can read as many unknown samples as we want, so long as they're at the same temperature as our standards were. And then we can use the calculator in the Excel document in order to find what that raw reading is in the unknown sample or samples. Okay, so this is the Excel document that I've been talking about. It's really simple. You can make it on your own if you would like. And what we have here are the alcohol percentages, the standards that we'll be using. So we'll be doing each sample twice or in duplicate. And then we'll be entering the raw readings here in this blue column. And then once we do all of our, once we run all of our standards in the detector, then this equation on the graph will update. And we'll take this really small number here with the E negative something, and we'll put it in the coefficient box. And then we'll take the exponent, which is this number up here, 3.154, and we'll put it in the exponent box. Now, once we do that, it will update all of these columns, and it will also update this calculator down here. So it will give you the prediction that the equation that you entered in would have given with your standards. It'll give you the error, and then it'll also give you the percent error. Ideally, your percent error is less than 20%. The other fancy thing that you can do is with this calculator down here, you can enter any of your unknown samples that you run. Say, for example, we get a value of 400 for our raw reading for the kombucha that we're testing. Then it will give you the alcohol percentage predicted by the equation on the graph. So I tried to make this really easy to use. Of course, you can make one for your own or just contact me and I can send it to you. It's really easy. Even if you don't have one of these detectors yet, I'd be more than happy to send it to you. So let's get started with actually running the samples and seeing what readings we get for this graph. So a few things to note is that you can see I have a relatively small volume of all of these samples that I want to run. Ideally, like I mentioned in the dilution video, you have a large stock of these standards in a fridge, and then whenever you need to calibrate the detector, which should be ideally every time that you use it, but worst case, you're at the very least using the same calibration temperature. However, for the sake of this video, I have small volumes of these standards just for the sake of demonstration purposes. So, like I mentioned previously when we were looking at the graph, is we're going to do each of these samples in duplicate. So we're going to start with the smallest alcohol volume, which is 0.1%. We're going to grab a sample tube that's been rinsed out and just pour in about 20 mils, like that. So we have our 20 milliliters of 0.1% alcohol content standard. We're gonna screw it into the detector, and we're gonna wait for a reading to come up on the screen. Now, again, we're not going to be looking or caring at all about this percent reading. So it happens to be just about perfectly right. That this 0.1% is actually 0.1%. But for the purposes of this video, we're only going to be looking at this raw reading here, which seems to be stable at about 450 maybe 459. We'll say 459. We'll type that into our Excel graph, and then we'll continue with other samples. All right, so we have our empty rinsed out test tube and our 0.1% standard again. This detector has been running for a minute, so hopefully it's cleaned out any air that might still be in there. We're gonna pour another 20 mils. Again, the volume doesn't have to be perfect. And we're gonna screw it into the detector and see what number it gives us. Now, especially on the lower percentages, you might be a little worried that you get very different readings on the raw values. However, it's perfectly fine. Just keep going with the measurements, and once you're finished with all of the samples, you'll see that the curve on the graph matches the data nicely. So we're getting about 458 this time, which is one less than we were getting last time. Maybe we are getting about 459. You don't have to be perfect with these, just make your best guess. We'll say 460. That's what we're looking at, 460. So we've put 460 into our Excel document, and we're gonna move on with the rest of the samples. So I'm gonna do the exact same thing that I did with this 0.1% standard. I'm gonna do it with the 0.25%, 0.5, 1%, and 2%. Now, as I mentioned in another video, the detector is most accurate between 0.1 and 1%. And part of the reason for that is because the standards that we choose to run to calibrate the detector are mostly within that range. So if you know that you'll be testing a lot of 1% alcohol or something around 1%, then maybe you want to choose your standards to be around there. So you might want to say test 0.5, 0.75, 1, and 1.25, and maybe 1.5 instead of the set that we have here. So you can change that in the Excel document, of course, and the more standards you use around the alcohol percentage that you're testing, the more accurate the detector will be. So again, we're going to test all these samples, and we'll be back with the results in the graph. Okay, so we've run all of our standards now, and I've typed them all into Excel. The last piece of data that we need to gather is for the kombucha that we want to test. So I would recommend measuring your standards and your samples and collecting all of the numbers and then putting it into the Excel document, just to prevent any bias. You might be like, oh, the kombucha is reading a little bit higher, maybe I had it too warm or something like that. So here our kombucha is reading about 764. That's what we're gonna say. Maybe 760. We'll say 762. Okay, so we've collected all of our data. This is all of the data here, and it's created this new curve. And you can see that our R-squared value, which is an indicator of how well our line fits our graph, is 0.99 something. It's best if it's 0.99 something, but if it's 0.98, you're probably fine. So you can also see that our equation has changed since we put in new numbers. So all of this looks wild. Our error is really, really high, and that's because we have yet to change our constants up here. So our new constant is this really, really, really tiny number here, this one, and our new exponent is this, not so tiny number up here. So in order to enter these, this is scientific notation, so you see the E -16, so that means you're going to have 15 zeros after the decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 zeros, and then 2053 is our number. And you can see that Excel has automatically put it in scientific notation, and it is the same as the number on the graph. Now our exponent is just 4.7, let's see, 69. So our whole table has updated, and you can see the predictions here for the standards that we ran. You can see the absolute error, which is just the prediction, or it is the actual percentage minus the prediction, and then the percent error is the absolute error divided by the actual alcohol percentage. So you can see our percent error is all less than 20, which is really good. And then you can see this table down here has also updated. So I put in our kombucha sample value, which was 762, and the alcohol percentage. This cell uses the constants up here. So that's updated as well, and we can see that our kombucha sample was reading 1.14% alcohol content. Now, fortunately, I'm not selling this kombucha. This is just for my own personal consumption, but it's interesting to know the alcohol percentage of my kombucha. Okay, so you can see even the slightly more complicated version of using this detector is really not that bad at all. Most of the work comes in preparing the 5 different alcohol standards. Once you prepare your dilutions, you have a storage of them in the fridge, and you can just pull them out whenever you need them. And running all of those standards only took me about 5 or 10 minutes. So preparation of the standard curve only takes about 5 or 10 minutes, and you get much better accuracy with the detector. I hope this video has been helpful. If you have any specific questions, feel free to contact me in the email address below. Thank you for watching.